Hey everybody, this is Craig at Vitex, and today we're going to shine some light on AECs and why they're important. So if you're in a data center, especially if you're working on something like 400 gig, you may want to keep a listen because we're going to go through some of the options that we have. So traditionally, if you're in really short areas, a lot of you are going to be familiar with what a DAC is. So that's a direct attached cable, and it's used in a lot of data centers, especially for very short reaches. But we have this new product offering that has come out not too long ago, and we're going to talk about why that could be a good solution for you. But first, we want to just kind of tell you about some of the names that this goes by, because depending what you look up, you may find this under different names. So kind of to quote Shakespeare, a rose by any other name. It may work really good in literature and if you're stuck up on a balcony, but not as much in optical communication. So the product we're talking today about is the AEC. This is the active electrical cable. You may hear it referred to as an ACC, which is an active copper cable, or an ADAC, which is just the active DAC. So what does this do and why do you need it? So as I mentioned before, DACs have a really constraint when it comes to length. But let's just imagine we're in a situation where we're operating within those constraints. So we can see our input, what's coming on one side of the cable is what we're going to get on the output. So there's really nothing for us to do here, and this is totally fine. So let's talk about that situation where we're going past the reach of what a DAC can support. And so you have two options that you're really going to look at from a technical space. One is going to be the redriver. And this is important because as the signal goes farther and farther in the reach, you're going to lose amplitude. So to get that back, we need to apply more gain to it. So this is what the redriver does. It allows us to increase our gain on our signal and results in a longer reach. So let's just assume that gain is not our problem, and instead it's something related to time alignment. We could have an alignment kind of skewing going on. So that brings us to the AEC retimer option, where it's actually going to use a CDR, or a clock data recovery, and it's going to realign that timing so we get the high quality signal that we're expecting. So what does this mean in terms of the kind of support and benefit we're going to get from it? So our reach is going to go up, sometimes 5 times compared to a DAC. And if we're looking at compared to other solutions, DACs really have the cable gauge, which is really thick. And if we want to reduce that, we can look at AEC as an option of this. So compared to other solutions, we're going to see a really big drastic weight change, and we're going to see the diameter of our cable drop. So this is important when you're looking at things like thermal management and airflow in data centers. So what else does AEC bring to you? So it brings in a lot of DDM functionality, so you can do some pretty cool testing and you can actually get reports from it. There's also the possibility of custom algorithms. So this will do things like eye alignment, and it will check for things to improve our signal quality even more. So actually, as our quality is going up, our bit error rate is going down. So we can see drastic improvements in our bit error rate, both over the distance that a DAC supports and as well as reaches further. So let's talk about some of the pros and cons why we would use an AEC versus a DAC. So DAC has a really great low latency, which is super awesome. So especially in like 400 gig applications, this can be very important. And our power consumption is also really low. So this is super important. But the bad part of this is we can only go a certain distance in that. So what if we want to get past that that distance? So we bring in the AEC redriver, and again, this is just upping our gain. So we can still keep a low latency, low power, and we get this nice extension of reach. And in our other option, when we do our clock data recovery, we are going to see the latency suffer a little bit, and there's going to be a slight increase in our power consumption because we have more active components in there. But we're going to see this nice super jump in reach, and we're going to be able to get distances that we can't with a DAC. So another important consideration is the cost. So when we look compared to a traditional DAC solution, the AAC with the redriver, not too much more money. You get a little bit of increased cost when you go to a retimer, but if you compare this to other solutions like AOCs or transceivers, it is definitely low. So if you want to find out more about this, feel free to give us a call, reach out to us in our New Jersey office, and that's all for this time. So until next time we talk, I'll see you then.